grade advanced class. Let's go ahead and knock this homework out. I got all the odd ones. So let's find the value of x so that the ratios are equivalent. I got 2 to 7 over here. That's 2 to 7. Oh, I see I did something a little different here. So what I'm doing is just going to reveal and then explain. I got 2 over 7 equals 8 over x. When I cross multiply, 2 times x has to equal 7 times 8. 7 times 8 is 56. 56 divided by 2 will give you 28, so x is 28. For number 3, I got 9 over x, and it equals 58 over 8. So now I'm going to have 9 times 8, that's 72. That's going to equal x times 54. When I divide 72 by 54, I get 1 1/3. All right, let's go to number 5. Number 5 says I got 42 divided by -6. We're just finding the quotient. Well, 42 divided by 6 is 7, and a positive divided by negative is a -7. So the quotient is -7. And number 7, we got -44 divided by -4. Negative divided by negative is a positive. And 44 divided by 7 is 11. So we should have 11 for our quotient. Let's go to number 9 now. Number 9 says, solve the inequality, graph the solution. Well, if I solve this inequality, I'm going to have to multiply by 3 over 1 to get rid of 1 over 3, which means I'm multiplying by 3. So I'm going to have to multiply 3 on this side. P will be greater than or equal to 12, because 4 times 3 is 12. All right? And it doesn't look like this one. Oh, there we go. And there we go, 12. P is greater than or equal to 12. When I put it in my graph, I put a solid dot. I put all the lines in that direction. Okay, as you've seen over here, we multiply this to 3 on both sides, just like I said. Over here for number 11, when I solve this, I have to divide by -2. Whatever I divide from one side, I do the other. But whenever I divide or multiply by a negative number, I just turn my symbol around. So this would be W is greater than or equal to 5, because 10 divided by 2 is 5. Actually, then -5, because 10 divided by -2 is -5. So W is greater than or equal to -5. Okay, W is greater than or equal to -5. Since it's bigger, or it can be equal to, I shaded in the dot on -5 and made all the numbers bigger than it. Or pointed arrow to all the numbers bigger than it. Number 13 says represent the table graphically. Does the graph represent a proportional relationship? Remember, whatever happens to one side has to happen to the other. 4 to 6 means I increased it by 1 1/2. 1.5, I multiplied by 1.5. Over here, that means I had to multiply this to 1.5, and I did, because 2 times 1.5 will give me 3. Now, over here, I also multiplied it by a number, but it's not going to be 1.5, because 1.5 would have gave me 9, right? Because 3 times 3, actually, no, 1.5. Let's use the calculator. I'm a little bit tired today. I'm pretty sure it's going to be 3, that'd be 4.5, something like that. So 3 times 1.5 is going to give you, 4.5. And I wonder if that's going to be the case over here. I kind of think it might. Let's check and see. Remember, we're multiplying. Well, actually, we're trying to find what did I multiply to 3 to get to 4. So I need not even worry about that, right? So if I'm going to do this, let's see, let's erase this off. So 8 divided by 6 is all I need to do. 8 divided by 6 gives me 1.3 repeating, okay? And 4 divided by 3. 4 divided by 3 is also 1.3 repeating. So I did multiply the same thing, but it's saying, does the graph represent a proportional relationship? Okay. Oops, sorry. Okay, 1.3 repeating. All right. And as you can see, the line passes through the origin, so x and y are proportional. Right? It doesn't matter that they're different, uh, that what we're multiplying by different. Actually, what really matters is taking the y and dividing it by x. All we've shown here is whatever I did to one side, do the other. And that does make it proportional. We could have said 4 divided by 2 is 2, 6 divided by 3 is 2, and 8 divided by 4 is 2. We're going by a rate of 2. Watch up here. 2 over 1 is 2. 2 over 1 is 2. 2 over 1 is 2. 1, 2 over 1 is 2. So these are proportional. All right, let's go to number 15. It says graph the equation. If I graph this, first I got to remember this is y equals 5x. That means this is really going to be 5 over 1. It means it goes up 5 and over 1. So on my graph, I'll show it going up 5 and over 1. Okay, they're trying to show here that when x is 0, then you get 0, 0, right? And that's true. Because when x is 0, y will be 0. Over here, when x is 1, 5 times 1 is 5. So when x is 1, y will be 5. All right, let's try number 17. Y equals x plus 2. This time we start at 2. And remember, x has really got a 1 in front of it, which means 1 over 1. So we will go up 1 and over 1. We're going to start at positive 2. Let me show you what I mean. And it looks like this has to be moved a little bit first. There we go. As you can see, we're starting at positive 2, because this is our starting point. And then we're going up 1 and over 1. Up 1, over 1. Up 1, over 1. Up 1, over 1. All right, that's how we'd graph it. Number 19 is equal, easy, because once again, we're going up 1 and over 1. This time we're starting at 4. So, remember, we're going to start at number 4 here, and then we're going to go up 1 and over 1. You might be thinking, Mr. Mendez, they went up more. Look, this is a 6 next. They went up by 2s here. So actually, this is 5, right? And I would put this at 5. So they went up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. All right? Number 21. This time, we're going to go up by 3 and over 1. So I think we're going to have to move this again. Hold on a second. Maybe not. Okay. Yeah, I don't see where they did that here. So if we were doing this graph, I know it's 3 and over 1. So I'm going to put this as 1. Okay. I'm going to put this as, well, we got a 2 over here. So let's just try as 1, 2, 3, 4, 5, 6. And remember, we're starting at 2. So we're going to start here. And then our line's going to go up 1, 2, 3, and over 1. And if I get 1, 2, 3 again, or this is 2, this would be another dot right here. So our line's going to go through number 2 and through these dots as well. All right, we're off to number 23. This time it starts at 8. I'm going to make my lines here and here. This time it says it goes up 2/3, 2 over 3. So this is kind of different. What it means is we're going to have 1, 2, 3, 4, 5, 6. Oof, that was not even. 2, 3, 4, 5, 6, 7, 8. And over here it says positive 8. So we're actually going to turn this into 16 of them. We'll do the same thing over here. This is 1, 2, 3, 4, 5, 6, 7, 8, and this would be 16 when we cut each one in half. And so if we start at 8, we'll be at 1, 2, 3, 4, 5, 6, 7, 8. So this would be 8 right here. That's where our starting point is. And then we're going to go up 2 and over 3. So up 2 means 1, 2, and then over 3 means, let's see, here and here. All right? Up 1, 2, over 1, 2, 3. Up 2, 1, 2, over 3. So that's 1, 2, 3. We'd be coming straight up over here. As you can see, we're going to get a line that comes through here and these just like that. Okay? Let's see. Number 25. This time we're going to start at 12. So I'm going to make my scales by 10 this time. All right, so this is going to be 10, 20, 30, 40, 50, and 10, 20, 30, 40, and 50. And this time I have to mark it because no one's going to know I went up by that unless I show it. All right, and the same over here. All right, so if my starting point is at 12, then 12 would be about right here. Okay, maybe even a little bit lower than that. Right there. All right, and then I'm going up to point 2.5, right? So how would I know this for sure where I'm at? Well, if I go up 2.5 from 12, let's see, when will I get to 10? That'll get me at right over here at 20.5, right? So yeah, that would be, yeah, because that's a quarter ways up. This would be about 2.5, so this would be about 2.5. All right, and so if I go up by 2.5 each time, I'm going up 1, 2, and remember this is going to be 1. Uh, so by the time I've gone up 1, 2, 3, 4 to get to here for 10, I will have gone for here. I'll need to go all the way to 20 to get it by 5, which means I'll be all the way up here. See, that's, we start at 12, so that's 40, or that's 4. This would be 8. This would be 12. And this would be 20. And yeah, no, 1, 2, 3. Yes. Actually, that's going to make 40. So I'll need to get to, let's see, 2.5. And each one of them is going to be 4 to get to 10. So 1, let's see, if this is 4 times, 1, 2, 3, 4 would be about right here. So we'd be about right there at 10. Okay. And let's see, that would put my line about here to here. Another way you could show this will look a little different. Bring it over here. because you don't have to have the scales the same. I know I did it on that one, but in reality, you could have them much different. Like on this one, they're showing the X's are in ones and the Y's are in eights. And by doing that, you see how the arrow looks like it's going uh, up at a less quick rate, but really for every, uh, let's see what we did over here, for every 10 it went, and let's see, because that was four of them, so let's see, one, two, three, four, that's going to be, four of them would put me at one, two, three, four, and I've got 20, at five of them will be 24. So at five, I would have about 24. See that? But the rates are the same. We just did it a little bit different here, showing map to map. All right. Let's go to number 27. The number of people, Y, entering the Dali Museum in St. Petersburg each hour is X, can be represented by Y equals 20X. Graph the equation. After how many hours do 120 people enter the Dali Museum? Okay, once again, we're making a graph here. Okay, and this one they're talking about people each hour, X is hours, and it says people will be 20 for every hour, right? So we're talking, I'm thinking if they want 120 people, about how many hours do 120 people are? So the bottom is going to be hours by X. Okay, and I'm going to put this by 50s. 50, 100, 150, 200, 250. This would be 200. And let's see, since we're talking about time here, how many hours, I'm going to make this into hours. Remember, uh, 20 over 1, and it doesn't have anybody starting to come in at the beginning, which means this is proportional. It's coming straight through the origin. 20 over 1 is going to put us, well, if this is 25, and then we could say this was 1 hour, 2 hours, 3 hours, 4, 5, 6, 7, 8, 9. So at 1 hour, we'd be at 20, and that would be about right here. We could even put 1 and 20. Now what is proportional to that? If I got 20 over 1, and I know I'm looking for 120 people for X. We know that this is going to be, through cross multiplication, 20X equals 120 times 1, which is 120. I divide by 20 to get X by itself, which leaves me 6. So I could say 1, 2, 3, 4, 5, 6 is going to give me 120 people. Okay, so let's see what happens if I was to do it by 5, right? Because 5 would be 100 people. So I could do here and go to 5 and then come right there at 100, right? And then I'll put my line through here. I could do a couple of things here. and I should do a couple of things. One, I'm going to mark my 6 so I know what my answer was. And that's going to be, oh, sorry. 6 and 120. All right. I could even put 5 and 100 over here if I wanted. All right. Let's go ahead and move down to number 29. It says identify the proportion relation. Tell whether x and y are proportional. If so, find the the constant and the proportionality. Okay. So remember, we can simply take y over x. This is going to be 0 divided by 1/2, which will, oh, sorry, 1/2, which will give us, wow, I'm just goofing this up. 0 divided by -2, which will give us 0. Then we have, and that tells us already this is messed up. Because remember, for it to be proportional, has to go through my origin and be straight. But this is telling me when x is at -2, -2 over here, then y will be 0. Okay, so that tells me already that it's going to start here. So that's not proportional. No. No. All right. How about this one here? We got 2 divided by 3. That's 2/3. 6 divided by 4. Well, both of those are divisible by 2, right? So that's also 2/3, right? Because 4 divided by 2 is 2, and 6 divided by 3 is 2. 9 over 6, right? Or 6 over 9. 6 divided by 3 is 2. 9 divided by 3 is 3. And 8 over 12. So 8 divided by 4 is 2. 12 divided by 4 is 3. This is proportional. So is it proportional? Yes. Okay. And if we want to put something here for an explanation, we could start with this one saying, not all y over x values are the same. Okay. And for this one, we could put all y over x values are equivalent. Okay. And let's try this one, 0.5 over 1. Let's just use our calculator, make it nice and easy on us. 0.5 over 1, 0.5 divided by 1, 0.5, right? Now let's try 1.5 divided by 3. 1.5 divided by 3 also gives us 0.5. Let's try the next one. 2.5 divided by 5. That's 1.25. So let's see. Let's try to remember here. This was 2.5 divided by, oh, I put it by 2. Look at that. Okay, 2.5 divided by 5. That's 0.5 as well. Now 3.5 divided by 7. 0.5. So you can see clearly that whenever we take the y and divide it by the x, okay, each of these is going to be equal to 0.5. So again, we can say all y over x values are equivalent. This is proportional. All right, so now we're on to number 35. A car travels 75 miles in 1 hour. Identify the constant proportionality. The constant is 75 in the situation, 75 over 1, right? So K is 75. Actually, Y, I'm sorry, it should be, but the book wants to call it K. So K equals 75. Okay, if I was, that would be my constant proportionality, all right? Number 37, 15 pans con bistec or con bistec. That's a type of steak in 30 minutes. So it should be 15 over 30, which is equal to 1/2. So K equals 1/2. And number 39, interpret each plot point in the graph and identify the unit rate. Well, we're talking over here, that's 1 and 5. So this would be, let's see, interpret each plot point. So 1 is going to be 1 hour for $15, right? Earnings. So $15 per hour. $15 per hour. Okay. Then there's another one for $60 per hour and $60 per hour. The rate is K equals 15. That's the rate. Okay. And I think that's all of them for me, which means the rest of them are for you. Have a great night, and I'll see you